Hello, algebra students. My name is Miss Elsner. I am coming to you from the Maricopa campus. I hope you guys are all doing good. We have lesson 85 today for algebra, and it is one of my favorite lessons. I always say that to my first and seventh hour. They know that I basically say that all the time because algebra is my favorite subject in the whole wide world. Today's lesson is going to be a little bit of geometry and a little bit of algebra mixed together, which is my favorite. And it is review, as you can see up here, and I hope you get this into your notes at this time. Lesson 85 is going to be solving problems using the Pythagorean theorem, and we love the Pythagorean theorem. You learned this in 6th grade with me. My 8th graders had me for 6th, 7th, and 8th grade, you poor things. Just kidding, it was wonderful. And so it's just a review. It's a nice, easy lesson, and it is my first one that I'm recording, so I apologize in advance. Okay, so let me try to get this on the screen. Sorry about that giant shot of my head. Okay, well, I'm just going to go with that for now. And maybe that. Okay, here's our objective for today. Students will be able to analyze right triangles by using the Pythagorean theorem to find missing side lengths. Okay, we've done this before. We know all about it. Okay, what we do need to make sure that we remember and write down is our math language. And in our math language, we're talking today about right triangles. So instead of writing this, I would say let's just draw it. Let's draw a diagram. Draw your best right triangle. Okay, put your little marking in there of your square box so that we have to believe you that it's a right triangle, whether it looks like it or not. And let's label the hypotenuse. The hypotenuse is the side that is across from the right angle. Okay, so this side is my hypotenuse. Okay. The other vocabulary that we need to remember is the legs, or are the legs, and those are the sides that are actually touching, they're connected to or adjacent to the right triangle, or the right angle. So we're going to say that this is a leg, and this is a leg. So make sure that you have that diagram. Once again, this is just review for all of you guys. Just review. Okay, here is our Pythagorean theorem. This is a rule. I make my class write these down. Anything that's in a box is a rule. You do not need your book open for my class. My class, I usually have everyone close up the book because everything that you need is on my PowerPoint. Okay, so get this in your notes. Most important part, we've got Pythagorean theorem. Pythagorean theorem is a squared plus b squared is equal to c squared. The A is going to be a leg, the B is going to be a leg, and the C is always going to be our hypotenuse, which is really important. Oh, it's finally sort of straight. Okay. All right. So the hypotenuse is always on the other side of the equal sign. The legs are always being added together. Feel free to pause the video when you're working on these, and I'd like you to give this one a try. Pause the video, and then I will work it out for you or with you. So pause the video, give it a try. You're finding C, which is the hypotenuse. All right. I'm going to start solving this thing. We're going to write down the algebra, which is a squared plus b squared is equal to c squared. It doesn't matter which leg you say is A and which leg you say is B, as long as you have both legs on one side of the equal side and you're adding them together. So normally just the first one, the one that comes first, closest to, I don't know, like if you're reading a sentence, I usually say that's my A. So it's going to be 6 squared plus 8 squared is equal to c squared. Okay, 6 squared is 36. 8 squared is 64, and that's going to be equal to c squared. 36 plus 64 is going to equal 100. And in my class, I always ask, how do you unsquare something or take away the square root sign? And by doing that, we have to find the square root. So we're going to square root each side to get that c all by itself. The square root of 100 is going to be equal to 10. The square root of c squared is equal to c. So we have our side length is going to be c is equal to 10. This guy on this side is equal to 10. Alrighty. Moving on to the next one, I'd like you to try this one on your own. Please find the side length t to the nearest tenth. Okay, so we can see that we have the 4 and the t are our legs. They're connected to this square root. Or not to the square root, but to the right angle there. And I guess you can see that. All right, so you can pause it and work this one out. I'm going to get started on the problem so that I don't take too much of your time. We've got a squared plus b squared is equal to c squared. I know that t and 4 are both the legs, and the 7 is the hypotenuse because it's across from the right angle. All right, so I'm going to say t squared plus 4 squared, and you can have it in any order you want to, those legs, is equal to c squared. Okay, t squared, I'm just going to leave it the way that it is. And then 4 squared is equal to 16. Oops, I wanted to put a 7 in there. Let's see if I could do that really quick. All right, so I wanted to put a 7 in here because that's my hypotenuse. And this is equal to 49. All right, so just in our regular old algebra, you know, so for solving a one-step equation, I guess it's a two-step equation, we're going to subtract 16 from each side. We want to get that t all by itself. Okay, and then we need 49 minus 16 is going to give us 33. Okay, now we need to find t. We need to get t all by itself. So we're going to find the square roots. Square root both sides. The square root of t squared is equal to t. And I'm just going to put this in my calculator because, I mean, I don't know this offhand, but I'm going to say here we're going to put in seconds square root 33. And if you put that in your calculator, you should get 5.74456267. But it says that we're going to round it to the nearest tenth. So don't forget to round it if it asks you to. So to round that, that's going to give us a 5.7. And I need to make approximation marks here because I am rounding. So it's approximately 5.7. Alrighty. Next step, we need to find the side length k. Okay, so go ahead and give that one a try. Make sure it's on the screen correctly. Looks pretty good. All right, so we have a right angle here. The legs are connected to the right angle, so we've got the k and the 5, and then this is my hypotenuse over here. So I need to add k squared plus 5 squared is equal to the square root of 61 squared. So give that a try. You can pause the video. And then I'm going to work it out. We've got a squared plus b squared equals c squared. Okay, I'm going to say that I've got k squared plus my b I'm going to say is the 5 squared. It doesn't matter the order. I just say the one that's closest to me, and the one that comes first is my a, but that's just the way that I do it. Might be weird for you. Okay, and then I've got, can go ahead and solve this. 5 squared is equal to 25. And then 61 squared is just going, the square root of 61 squared is just going to be a plain old regular 61. Okay. I need to get that k all by itself, so I'm going to subtract 25 from each side. That will leave me with a k squared on the one side, and it's going to leave me with 36 on the other side. In order to get that k all by itself, remember, we need to take the square root. And the square root of 36 is equal to 6. So k is equal to 6. Okay. Any questions? Just kidding, I can't hear you anyways, but you can always contact me and or email me or ask your teachers. Like I said, though, I think this lesson's pretty easy for us because it is all review. Okay, we need to find side length m in simplest radical form. So be careful because radical form means that we're not going to put the square root in our calculator. You're going to leave the square root sign. So we're going to find an exact answer rather than an approximation. Okay, so we are going to find side length m and locate our right angle, which is right here. Those are our legs. So that means that I need to add 12 squared. This is going to be my A and my B. And my hypotenuse this time is going to be the M. So you can go ahead and pause it and work it out. Okay, I always say the one that's closest to me, I'm going to make my A. So I've got 12 squared plus 8 squared is going to give me my m squared. Okay, 12 squared is 144 plus 8 squared is going to give me 64. And I've got m squared. And then if I add those two together, it's been a while since I've been in the classroom because I've been in break, so I literally just put that in my calculator, which is a little embarrassing. But if I add those two together, I'm going to get 208. And that's m squared. All right, so now what I need to do is I need to take the square root of both sides. So in order to take the square root, I need to figure out what times what is going to give me 208. Okay, so I need two numbers that are going to give me 208. And there's not like an exact number. It doesn't have a perfect square. So what we need to do is you need to factor and you need to kind of play around with numbers a little bit and think about things like, I don't know, that you can multiply together that are going to give you, I know that 12 times 12, will give me 144. Let's see here. So I'm just going to play around with some numbers. And 208. I don't know. You could make a factor tree if you want to. I kind of love factor trees. 208 divided by 2, we could try that. 208 divided by 2 is going to give me 104. Okay, so I've got 104. I don't know, I could try dividing 104 by 2. That's going to give me 52. 2 times 52. Oops, that one's not prime. Going to be 52 over here. Okay, so if I divide 52 by 2, I could say 52 divided by 2 is equal to 26. So I can say 2 and I could say 26. And then what's going to go into 26? We could say 2 and 13. And finally, we have a prime number there. So we've got 4, we can say the square root is 4 times 13. And I know that 4 has a perfect square, so I'm going to actually pull 2 out of there. So the square root of 4 is going to be 2. Actually, we've got 2 times 2 is 4, and 2 times 2 is 4. So we've got 16 under there. Whoops. that up. I've got 1, 2, 3, 4 2s. So that's going to give me 16 under there. And 16 times 13 is going to give me 208. And then over here, I've got 16 times 13. The square root of 16 is 4 times 13 is equal to m. Okay, sorry, that one was a little bit messy. Alrighty, and here it is a lot neater. All right, next up we've got the converse of the Pythagorean theorem is also true. And if you would you please write this down? We have converse is a lot in our geometry lessons. What this is saying that if a triangle has side lengths A, B, and C that satisfy the equation a squared plus b squared is equal to c squared, then the triangle is a right triangle with legs of lengths A and B and hypotenuse of length C. Okay, so get that down in your notes. So they're saying if you can plug in the numbers from a triangle, a triangle that's in question into this equation, and if it comes out to be true that the legs, that the suspected legs, if you add them together, if you square them and you add them together, and the hypotenuse, if you square that, they're all going to be equal to each other, then that means the triangle is a right triangle. Okay, we've got Pythagorean triples. Pythagorean triples. Pythagorean triple is a group of 3 non-zero whole numbers, A, B, and C, that represent the lengths of the sides of a right triangle. Two triangles whose side lengths are Pythagorean triples are shown below. If you square the 3 and you square the 4 and you add them together, you square the 5, it's all going to be equal to each other. Okay, so what I'm saying is I'm going to grab this guy and this guy. I've got 4 squared plus 3 squared is equal to 5 squared. That's going to be 16 plus 9. That's a square. And if you add 16 plus 9 together, it will give you 25 is equal to 25. And that shows you that this is a right triangle. Okay, this is a Pythagorean triple. This one, the same exact thing. They're going to be whole numbers that are going to, we can use a squared plus b squared equals c squared, and we are not going to get any sort of an approximation. It's going to be a whole number. Okay, so we need to determine if this is a right triangle, if it has side lengths of 9, 40, and 41. So what we're going to do is we're going to substitute it into our equation that we have been using throughout this entire lesson. A squared plus b squared is equal to c squared. So we've got 9 squared plus 40 squared, oops, that should be an equal sign, is equal to 41 squared. Give it a try. Use your calculators. Or not, maybe you don't need to. Okay, so 9 squared is going to be equal to 81, plus 40 squared is going to give me 1,600, and 41 squared is going to be 1,681. If I add those together on the left-hand side, that's going to give me 1,681 is equal to 1,681, and the equation is true. Therefore, this is a right triangle. Okay, so I would say, yes, this is a right triangle. Okay, is true. Okay, do the same thing with this one. We've got, our sides are going to be, A is going to be 8 squared, B is going to be 10 squared, or those could be flipped. And the longest side is the hypotenuse. The longest side is the hypotenuse. So whichever number is the biggest number, that's going to be your C. Okay, so if we would draw this thing out, the longest side is always your hypotenuse. The shorter sides are going to be your A's and your B's. Okay, 8 squared is equal to 64. 10 squared is equal to 100. 12 squared is equal to 144. And if I add those together, I'm going to get 164 and 144. Are those equal to each other? No, they're not. So we're going to put a little slash through the equal sign, and this is not true. It is not a Pythagorean triple. And not a Pythagorean triple. That last one was not a Pythagorean triple. I don't know if I said that correctly, but since it didn't work, it's not a Pythagorean triple. All right, let's give this one a try. We have, we're going to do, I would say, okay, the square root of 170. The square root of 170 is going to be, because I'm trying to figure out like which side is the smallest one. The square root of 170 is going to be 13.0384041. So if I can't even use this, and the reason why I can't use this is because all of the side lengths need to be whole numbers. So really, I don't even have to figure out which side is the longest, which this one would be the longest because it's going to be 13 and something. But it's not a triple, and the reason why it's not a triple is because this is not a whole number. That is an irrational number, and this is not a triple. So this one we would say is not true. We could say false. False, if I could spell false, not a triple. All right, last one. A ladder in the diagram satisfies the 1 in 4 rule. A rule of thumb for the safe use of ladders. This rule states that when the bottom of a ladder is positioned X feet from the base of a building, the top of the ladder should reach a point 4x feet off the ground. Find the length of the ladder in the diagram. Round your answer to the nearest tenth of a foot. Okay. So give this one a try. You can pause the video if you'd like to. Notice in the diagram that this is the angle of the ladder to the building, from the ladder to the building, is a right triangle. It's a right angle. So we can use a squared plus b squared is equal to c squared. Okay, so to solve this thing, we're going to say a squared plus b squared is equal to c squared. We've got 5 squared plus 20 squared is equal to c squared. 5 squared is 25. 20 squared is 400. C squared. Okay, if you add those together, you're going to get 425. And we need to take the square roots of each one. All right, so if we take the square root of 425, I'm going to put it in my calculator. The square root of 425 is going to be equal to 20.61552.813. It asked me to round it to the nearest tenth of a foot, so I'm going to round that answer to 20.6. So my length of C is going to be approximately 20.6, and that is feet. All right, so that concludes lesson 85. I don't know how long that was. Oh, we're less than 30 minutes. It surely felt like longer. I will see you guys tomorrow for lesson 86, and if you have any questions, please ask your teachers. Feel free to email me or hit me up on Google Classroom. And have a great day.